Okay, and number 10 here, I've got distributive that I need to do first. So I'm going to do that 2 times 3 and get 6, and that 2 times negative 8 and get minus 16x. Then do negative 6 times negative 8 and get plus 48x, and then minus 6. So now I'm going to bring everything else down. Why do I keep writing the wrong stuff today? Good grief. Okay, it's probably because it's late and I'm tired. All right, so now I have terms that I can combine on both sides. Because over here, I've got x's. So 6 minus 5x is just going to leave me with 1x. Because if I have 6, take away 5, that leaves me with 1. Here I've got this negative 16x and this positive 48x that can be combined. So that'll give me a 32x. Then I've got 6 minus 6. So really, that's just going to cancel and leave me with nothing. So I know this is when a bunch of you guys got confused because you're like, wait, now I've got an x and a 32x. Something's off here. And no, nothing's off. It just means that x has to be equal to 0. Let me show you why. So if I get rid of x over here, take away an x on both sides, don't forget that there is a 0 there. 32x, take away an x, will leave me with 31x. So then if I divide both sides by 31, 0 is equal to x. Remember, it becomes no solution or infinite solutions or something like that when you've got the same number of x's on both sides. So like if you had, just for example, like if this were a 32 instead, then it would be like an infinite or a no or something like that. But because they're two different numbers of x's on both sides, pretty much that's going to be your clue that your answer should have been 0. For number 11, we've got those fractions there. And I'm going to show you what I personally would have done, even though I know a lot of you guys would not have necessarily done it this way. I would clear out these denominators first thing, and I would do that by multiplying by the least common denominator. So I'm going to multiply everything by 6. Actually, you know what? Before I do that, actually, I'm going to combine these like terms that I have here so that I have less to multiply. So if I've got a third and I take away 2, that is going to leave me with a negative 1 and 2/3, right? Because if I've got a negative 2, subtract out that positive 1/3, leaves me with 1 and 2/3, which as an improper fraction leaves me with a negative 5/3. So now I'm going to actually rewrite this. So now this is x minus 5/3. And remember, I was able to combine those terms because they were both on the same side of the equal sign. Now I'm going to multiply everything by 6 in order to get rid of those denominators, because you know how I feel about fractions. So on the left-hand side, those are just going to cancel and leave me with a negative 25. 6 times x is simply going to leave me with a 6x. And then this 6 and 3 are going to cancel to a 2/1. So then all I've got is 5 times 2, which is 10. So that's going to be a minus 10. So now I've got a two-step equation that's much more simple for me to solve. I'm going to add 10 to both sides. That leaves me with a negative 15 is equal to 6x. I'm going to scoot this out over to the side since I kind of ran out of room here a little bit. I'm going to divide both sides by 6. So that leaves me with negative 15/6. And since both of those are divisible by 3, that leaves me with negative 5/2, which is my final answer. For number 12, I also have distributive property again that I need to do. So negative 7 times a is negative 7a. Negative 7 times negative 5 is plus 35. Now I've got variables on both sides to get rid of, but I notice this time, or I should notice, something's up here. Because I've got a negative 7a, negative 7a, but they're paired with two different constants. The one right here on the left that has the bigger constant is always going to be heavier because I have the same number of A's on both sides. Okay, so that can't ever be equal. It can't ever balance out. So this is a no solution. Another thing I could have done, just to show you, I could have finished solving it all the way out by adding 7a to both sides. That would leave me with 35 is equal to 33, which is another clue that that is a no solution. Number 13 asks for 3 consecutive integers. Remember, consecutive is back to back to back, like 1, 2, 3. So they increase by 1. So that means I'm adding, remember my smallest one is an x, plus my next one would be x plus 1, plus my next one would be x plus 2, is all summed up to 126. So that's my equation, x plus 1 plus x plus 2 equals 126. So I'm going to add all those together. So that should be 3x plus 3 is equal to 126. Subtract 3 from both sides. Divide both sides by 3. X is equal to 41. So since the smallest one is 41, the next one must be 42. The next one must be 43. For number 14, because it's an absolute value equation, I basically have to solve it twice. So I've got my case 1, where I have to say, let's assume that 18 becomes positive. So I'm going to take the 3p minus 6 and solve it as if 18 were a positive number. Add 6 to both sides. 3p is equal to 24. Divide both sides by 3. P could be equal to 8. Case 2 is where I solve it as if 3p minus 6 were equivalent to a negative 18. So I'm going to add 6 to both sides. Divide both sides by 3. P is equal to negative 4. So the two answers, remember I put them in my little brackets, are negative 4 and 8. My answer right there. And this did not tell me to graph it, so I'm good. I don't need to graph it this time. Okay, number 15. I should look at 15 and know that something is wrong because nothing can come out of the absolute value and end up being a negative 3. So this is an example of what we call, you guessed it, no solution. For number 16, I personally would clear out those denominators and I would do it by multiplying by a 4 and a 7, the least common multiple, which of course is a 28. Or I can think of it as two separate terms. So I'm going to multiply this by 4 and 7 over here. Then I'm going to multiply the other side by 4 and by 7. So if I do that, that 4 and that 4 are going to cancel out, and that 7 and that 7 are going to cancel out. So I'm just left with 7 times n, which is 7n, and then 3 times 4, which is a 12. So I'm left with 7n is equal to 12. If I divide both sides by 7, remember that n is equal to 12 over 7. Remember, we like fractions. For number 17, I'm going to do exactly the same thing, except I'm just going to multiply by 8, because if I multiply both sides by 8, 8 will cancel out both sides of my denominator here, because it's the least common multiple. So 8 cancels out 8, which is just going to leave me with a 10. And then 8 divided by 2 is 4. 2 divided by 2 is 1. So then I just need to multiply 4 by both of those. So that's 4n plus 40. Subtract 40 from both sides. Negative 30 is equal to 4n. Divide both sides by 4. So n is equal to negative 30 over 4, which is the same thing as negative 15 over 2. Number 18 is asking us to solve for a. So I am going to do what I can to get a by itself. So this a is sitting here hanging out with a b that needs to go. So So I'm going to subtract b from both sides. So that's going to leave me with a u minus b is equal to ak. Then I just divide both sides by k. So my final answer is u minus b over k. I'm skipping number 19 since we just made that one a bonus. I'll come back to that later in class. Okay, so the part A is asking us to solve this formula for P. So I'm going to rewrite the formula over here. So C equals 8P plus 150. And I got to get P by itself. So I'm going to subtract 150 from both sides. That takes me to C minus 150 on my left-hand side is equal to A over P. Divide both sides by 8. So I can leave it as C minus 150 over 8 is equal to P. Then if Matthew can spend $270 on his birthday, how many people can he invite? Well, C is the cost he's got. So I'm going to take this C minus 150 over 8 that we just spent time finding. I'm going to substitute 270 for the cost. So 270 minus 150 over 8. 270 minus 150 is going to give me 120 over 8. And then 120 divided by 8 is 15. So that means he can invite 15 friends to his party. Okay, the last two, everybody's favorite, dimensional analysis. So it's talking about a swimmer. If each lap is 100 meters long, how many laps is equal to 1 mile? So I'm going to make myself a plan right here. So they gave us this conversion factor, which means I'm given meters. So I'm going to go from meters to feet, and then I'm going to go from feet to miles because that's what they're asking me for is miles. So here's how I'm going to set up my conversion factor, which a whole bunch of you guys did the setting up part right. Okay, so I've got 100 meters over 1, and I'm going to use the conversion factor that they gave me, which is 1 foot is equal to approximately 0.3048 meters. I'm going to put the meters in the bottom so that these meters will cancel out with those meters. Put my 1 foot on top. And then I know that there are 5,280 feet in 1 mile. So I'm going to do 1 mile, let me get rid of this here, over 5,280 feet. And again, I put the feet in the denominator so that it would cancel with the feet in the numerator. So then I'm just going to multiply all this straight across. 100 times 1 times 1 is 100. And then I'm going to multiply across the bottom. And if I do that, I'm just going to estimate at this point because it doesn't come out to be a very nice number. I'm just going to estimate and say 1,609. Now here's where a whole bunch of you guys went wrong. You did 1,600 divided by 100 and you got approximately 16 for your answer. That's not what you have to do. You do the top divided by the bottom. So it's 100 divided by 1,600, which is going to give you approximately 0.06 miles. So most of you guys did this whole setup part right, and then you didn't divide it right at the end. Okay, for number 22, a bunch of you guys didn't do dimensional analysis for this one, and I gave it to you because you got the right answer, but next time we got to do dimensional analysis, okay? I'll be more specific next time. So we're going to convert 1 foot to centimeters, and it gave us the conversion factor with inches. So that tells me that I'm going to go from feet to inches to centimeters. That's going to be my game plan here. So from feet to inches, there are 12 inches in 1 foot, and I set up my feet so that they're diagonal from each other so that they'll cancel. Then I'm going to use that conversion factor I was given in the problem, which is 2.54 centimeters, or in 1 inch. Again, I set these up diagonally so that they're across from each other. So because the bottom is pretty much all ones, all I really need to do to get my final answer is multiply across the top. So if I do 1 times 12 times 2.54, a lot of you guys got this one right. I end up with approximately 30.48 centimeters.